So good afternoon, everyone. It's our third CICS session. People just coming into the waiting room. I'm letting them in as fast as I can, but we'll look to start on time. Will's back for his second session with us. An intriguing title, which I don't know much about, I must admit. But it's not new in CICS, but it might be new to you. So welcome back, Will, and take it away.
Cheers, Rob. Thank you very much. And hello, welcome everyone. Thank you for joining us. It's a shame, of course, that we're not face to face, but I hope that this afternoon in the UK finds you all well. For those who don't know me, my name is Will Yates. I'm part of the CICS development team based in Hursley. And yes, this session, it's not new in CICS, but it might be new to you. It is a bit of a strange title. It's not the obvious, here's something new in CICS you've not seen before, and we're going to talk about it for an hour. So what is this session actually about? Well, as we all know, CICS over the past 50 years has evolved to become a very powerful mixed language application server. And in each release, we bring new capabilities, new features, new APIs that allow you to bring new applications to the platform, extend your existing applications, or maybe even rehost other application components from maybe a distributed platform inside of CICS. And each year, or each time we release a new version of CICS TS, we will go out to conferences and we'll talk about the new features that we've introduced into that version of the product. And we'll talk about it maybe for a year's worth of conferences, and then we'll start talking about what's going to be in the next potential release or stuff that we're delivering as part of a continuous delivery feature. That can have a problem because CICS is now a very big product and contains an awful lot of capability. And I remember being sat in Share a couple of years ago at the very last session of the week. And there was a lady at the front and she was talking about MQ and CICS and about how you can run a CICS Java application that uses JMS and how that can talk to MQ. And there was a gentleman in the audience that stuck his hand up and said, you trying to tell me I can do Java in CICS? And there was a little bit of a collective intake of breath. You know, someone didn't know they could do Java in CICS. And we took the guy to the side afterwards and said, yeah, you can do Java in CICS. This is how you do it. This is why you might want to do it. And he said, oh, that's fantastic. I never knew you could do Java in CICS. I've learned so much. So the point of this session is to touch upon some aspects of CICS, some of the capabilities of CICS that we've introduced in a prior release. So this isn't stuff that's just hot off the press. This is stuff that's been in the product maybe for a few releases, and perhaps try and share A, how it works, B, some of the scenarios that you could build with that capability, and then finally, the value that you could derive from using it. So we're going to be talking about four main features of CICS that have been there for a while and how they could be used. We're going to talk about channels and containers. We're going to break you in gently with that one. I think most people should know channels and containers, but we're going to talk about some of the uses of channels and containers, which you may not be aware of. We're then going to move into event processing and how that can be used to extend or to observe useful information about your CICS applications. We're going to talk about liberty, but in particular, link to liberty, and why that's useful when you're looking at rehosting Java applications back onto the platform. And finally, we'll talk about system policy, which is a little bit different from event processing, but allows you to police your applications in quite a granular way. So we'll make a start with channels and containers. Now, channels and containers, we got there first with the name container. We used the name container. We had a very, very particular use for the word container. And then these Docker chaps came along and started using container for something completely different. So we're not talking about Docker. We're not talking about deploying applications as a container. We're talking about how CICS uses containers to transfer data. And just a quick overview, this was introduced back in version 3 of CICS, along when we did web services. And the reason for its introduction was quite interesting. Zoom is moaning at me for some reason. Okay, thanks. Sorry about that. I had a little notification in my, I just wanted to make sure it wasn't a question. So when we introduced web services, it became clear that because we were now dealing with large amounts of XML wrapped data, and SOAP is quite a verbose protocol, we were probably going to end up having to deal and pass around greater or larger than 32 kilobytes of data at any one time. And we'd also need to perhaps segment that data. So, get the whole XML message and then split it up into its various pieces and process them separately. So we needed to change the paradigm of how CICS applications share data, from just having a big bucket to now having a way of transmitting perhaps smaller segmented buckets of data. So just as a quick overview, a channel is just a named read-write collection of containers, and a container is just a named area of storage, which can contain more than the 32 kilobytes of data that you'd have in a COM area. Now, all of this data is held above the bar in 64-bit storage, so there's plenty of space to go around. And when a program links to another program, it can just pass the name of the channel. And the program that you're linking to can read containers off that channel, add new containers, update the content of containers. And it's that ability to fragment data up that gives you so much more flexibility and capability than simply just having a bigger COM area. And one of those things that you can do is that a channel can be shared amongst multiple applications or multiple programs. So think about if you've got program A that needs to call program B, C, and D, and they all need to provide input to a response that program A requires in order to formulate its response back to the user. Doing that with a COM area, you may have multiple or one single large COM area made up of several chunks of data, each having to fill in its own little bit. And if any of those pieces changed, if any of those COM area structures changed, then it'd have to be updated across all of the programs. But if you use a shared channel, each program can just place its response of data, its chunk of the data, onto the shared channel. And that structure only needs to be shared between program A and the program that's writing the data, meaning that you can now have each program a lot better compartmentalized with just the data that it needs. And program A doesn't even need to be aware of all of the containers. Perhaps program C and program D could actually share a container to share some state between themselves. Program A doesn't need to know about that, because at the end of the task, then the entire channel and all the containers on that channel are automatically reclaimed and cleaned up by CICS. So it allows a set of programs that are collaborating together to just put bits of storage onto this shared channel in a very nice, well-structured and reliable, serviceable way, because it all gets cleaned up at the end of the task. But there's some things about the API, the channel contains APIs, are actually really quite useful. That speaking to some customers in the past, they've not all been aware of this. They've been aware of, well, I can just use a container and I can let me have a big COM area. But there's other aspects to the API that allow you to do other things. So one is doing exec-CICS assigned channel. So that will return to you the name of the channel that this program has been invoked with. Why is that useful? Well, maybe you've got one program that's accepting input from different parts of the organization. And one part of the organization has updated itself, and it's now going to use perhaps version 2 of the data interface to this program. Well, you could call it with a channel called version 1 or channel version 1 or channel version 2. And depending on the name of the channel, the program can then automatically work out what sequence of logic it should execute. So it means that you can now have dual paths through the data, not based upon a flag in the data, but on some meta information associated with that data. Programs can also browse the content of a channel, so you can see all of the containers that are on there. So you don't need to know in advance what container names are going to be on the channel. You can work that out programmatically at runtime. Why is this useful? Well, if you're dealing with a sequence or a multiple instances or an array of some sort of structure, then yes, you could put that into just one large contiguous piece of storage. But a slightly better way of handling that is to split it up into multiple containers, give them all a unique name and place them all onto the channel. The receiving program can then iterate over that sequence of containers without having to know the names of those containers in advance. And this structure, this way of just splitting it into multiple containers, allows the way of interacting with that data to be a lot more API driven, making it easy to understand what these applications are doing. You can also call Getcontainer to check if a container exists or not. So I can call a Getcontainer maybe on an error container. And if I get the container error response back, then I know the container did not exist on the channel. Why is that important? Well, I can use this technique of testing the channel for a particular container to ascertain the state of the program I've called. Let me give you an example. If I call out for a program with a channel, and then when control gets returned to me, I want to know, first of all, did that program succeed and do what it was meant to? Obviously, if it's appended, then that was quite a severe error, but maybe there was a syntax problem or that some data wasn't there, but the program needs to tell me that there was an error. Well, the first thing I could do is actually test to see if there's an error container on the channel. If there is, then I know that the program is in an error state and I should do some error processing. Whereas if the container's not there, I can use that as an assumption that the program worked successfully, and I can go and get its data container to work out what my response should be. So being able to test the channel for the presence of a container and using that as a flag is quite a nice technique to use in applications. And finally, of course, you don't have to just wait until the end of task to clear up the channel. You can delete containers yourself. And again, this is very much like doing the testing of a channel for a particular container's presence. In the CICS pipeline, when we're processing web services, we have this contract where the sequence of containers on the channel actually tell us what state of processing we're in. Should we continue to the next node in the pipeline, or have we hit an error and we should reverse and start going back upwards through the pipeline to return an error to the customer? And in order for this to work, each handler on the pipeline must delete a particular container to allow the flow of execution to proceed to the next handler. So actually using containers as flags on the channel can be a nice way of informing other programs in the application of the state of the application as a whole. So, like I said, channels and containers was just to break you in. I think most people will be familiar with channels and containers, but I hope there was some uses of the APIs there that were perhaps a bit more interesting and maybe something that you didn't already know. So now we're going to move on to the second area of event processing. So event processing was introduced all the way back in CICS version 4. So not as old as channel and container and not as old as web services, but version 4 of CICS still feels a very, very long time ago. And the point of event processing was to allow business level events to be detected from within a running CICS application and then emitted. And that emission of those events could be over any kind of transport. And then that sequence of events could be correlated, could be processed as a block by a third party to understand the state of the business. So there were two ways that you could capture an event using event processing. The simplest was through an explicit API call, exec_kick signal event. And what this would do is it would, at that moment in time, signal to CICS that it should capture and emit an event. And on there would be some information about the event, maybe some text or some data about the state of the application, and CICS would emit the event. The second way of capturing event was to create a event binding within the CICS Explorer. And what the event binding would do is basically pinpoint a specific exec_kick API call that you wanted to capture as an event. Let me give an example. Let's say I want to build or I want to understand every time a transaction completes. Now, when I say a transaction, I'm not thinking about a CICS transaction, so I'm not thinking about sync pointing. I'm thinking about maybe when a file is rewritten, because at that point we've persisted a piece of information to a file, and that is, from our business level, the transaction that we want, that we're concerned about. So I could, in my event binding editor inside of CICS Explorer, create an event binding to say each time the API call exec_CICS rewrite file is issued by a program, I want to capture an event. I can then provide a sequence of filters on that. So I can say only when a specific user ID is running the application, or maybe only when the application is running under a specific transaction ID, or maybe only when a certain program is running the API call, or when it's only a specific file. So not when all files are rewritten, just when this specific file is rewritten. I can also say only capture the event if a certain part of the data within that API call has been updated. So maybe only for files that have been rewritten where the new account balance is over a certain threshold. And I can also then only capture the event depending on the response of that API command. So only capture the event if the response from that rewrite command is normal. If it's duperec or not found or any other condition, don't capture the event. Once the event has been captured, it can then be emitted through a WebSphere queue, TSQ, TDQ, over HTTP, or we could drive a custom transaction adapter that's been written yourselves to do whatever you want to do. So the point of EP was to allow you to extend and to understand more about the applications that are running by allowing CICS to capture and emit these events, and then for those events to be processed elsewhere. They could be processed within CICS, but anywhere else would also be valid. So you could start to understand more about those applications. Now, the events themselves, because the amount of usages of this were quite numerous, there were quite a lot of characteristics that you could apply to these events to help you understand, or to only issue them in certain circumstances. So, for example, an event can be synchronous, which means that when the event is captured, the application that triggered the capture of that event should be suspended up until the point that the event has been emitted. So this means that you are obviously going to have a longer path length, but you are assured that the event will actually go. Asynchronous, the event will be captured, but then as soon as the event is captured, which is a very quick operation, execution will be returned to the program that triggered that event capture. And then asynchronously, that event would be placed into a queue and eventually dispatched for emission. The next set of characteristics was around the transactionality of the event. So you could declare an event as being transactional, which means it will only be emitted if the program that triggered the capture of the event hit a sync point. So this means that I can build up a sequence of events being emitted as part of my application, but they will only be captured and will not be try and work out what the past of emission is. I can't think of it. They'll only be executed or processed once that program has hit a sync point. If that program rolls back, then those events will be discarded because the triggering program has rolled back. Opposite of that, non-transactional, I think you can guess what that is, that the events will be emitted even if the unit of work rolls back. So they are that they will always be emitted rather than being waiting for the parent unit of work. And finally, priority. So you have a choice between normal priority and high priority, where in normal priority, we basically create a first in, first out queue. So the events that have been first written to the emission queue will be the first to be emitted. High priority events will jump to the front of that queue. So effectively, if you're a bit of a theme park nut, it's like buying a quick pass ticket to get onto your favorite ride. You can jump to the front of the queue. So like I said, these events are created or designed within the CICS Explorer. And I've just taken a few screenshots to show you what that looks like. So you can see I've got a whole range of points or capture points that I can declare in order to choose what API I want to base my event on. And I've got the signal event there highlighted, but you can see that there's a whole range of API commands, and this little view scrolls. So there are quite a few there, but obviously they're just off the range of that window. And note also that I can choose whether I want to capture the event before or after the command is executed. So I can say that I'm about to do a web read, but I want to capture the event just before I do the web read, or I want to do it once that web read command has executed. Now on the right, you'll see some system capture points. Now this was our first evolution of what eventually became CICS policy, which we'll talk about at the end of this session. Once I've captured my event, I also can then choose how I want to emit the event. So here I'm choosing I want to run a transaction start adapter, which is basically going to do an exec kick start of a particular transaction, passing it a user, or so using a different user ID or system ID if required. And then in the advanced options, I can choose the synchronicity of that event. Now, because I've chosen a transaction start event, that has to be asynchronous, because once we've done the exec kick start, we can't get back to that transaction. So by default, in this case, it has to be async. And I've also chosen that the event is of high priority, so it will jump the queue. It's got its quick pass, its fast pass ticket. And in this event, they're non-transactional, which means this event will always be emitted regardless of the driving unit of work. And just to show, there I've got a different adapter. This time I'm writing to a TS queue, so to write into a record on temporary storage. And I just need to fill in the queue name, and CICS will write an event to that queue. Now, one thing we've not spoken about so far is what's actually in these events. Well, by default, the most basic piece of information in the event would just be the name of the event. But you can also include any data you want, including data from the API call itself. So for example, if I'm capturing an event based on a file rewrite, I can capture information from the record that I'm rewriting to the file into my event. So if this is doing some sort of bank processing, I can capture account numbers, I can capture the amount, and I can take that and place it into the event myself. So what kind of scenarios can I use event processing for? Well, the most basic is really to simply observe certain elements of business processing. So for example, how many times a day does event X happen? Now, event X may not necessarily be just a simple count of a transaction, because there are monitoring tools to do that. But maybe this might be how many times a day does a certain update request happen where the user is of this type, or the amount that they are transacting is of this type, or they're purchasing an item that is of over a certain threshold. So it's allowing you to count things that are happening within the heart of your transaction processing that you may not be able to monitor in any other realistic way. And there are two implementation options. One, you can understand which API call that is already issued within your application is the point where that business event has occurred. And then you can use the CICS Explorer to build a EP adapter and capture specification to highlight exactly that single point in processing that you want to create an event for and allow that to be emitted. Doing it this way means you don't have to update any of your application code. The application code doesn't even need to be recompiled. It just runs as normal. And when the execution passes to CICS, as we call the API, we can understand at that point we want to capture the event. The second implementation option is to actually write some new code and augment that application to issue the exec kick signal event API call yourself. But of course, that requires you to make changes to the application code. Once the event has been emitted, it can then be processed by an event consumer that could create a KPI dashboard or do whatever you would like with that data. And on the CICS Dev GitHub repository, there are plenty of examples where we show you how to write an event consumer that you could then deploy to listen to these events. And that can run inside of CICS or outside of CICS. Let's take another scenario. This time, I want to create a cache of processed transactions. But I want to understand, I only want to cache the events that actually happen. So I don't want to just listen to work coming into the system. I actually want to provide a bit more logic about what's happening. So let's take the application prgbc here, which I have. It's going to update 3 separate files. And it's going to do that update within a single unit of work. So it's going to update 3 files and then sync point. Well, we're only interested if all of those updates happen and that sync point occurs. If the sync point rolls back for any reason, then we want to throw those events away. We wouldn't be interested. So how can we build that solution? So I can create an event very similar to the screenshots I showed you earlier, where I will detect a rewrite API call on that particular file. And then I'll declare that event as being transactional, which means that when those events are captured, they get written and are correlated together on a separate list by their unit of work ID. And then when the application sync points, either explicitly or at end of task, then CICS will go through that list of held or in doubt events, and it will find all of them for that specific unit of work, and it will emit that set of events. Now, because these events are asynchronous, the application processing isn't slowed down waiting for this processing to happen. CICS simply captures the event and lets the program carry on doing what it was doing. And when it finishes processing, we club all of those events together and emit them as a single entity. So this means that my application hasn't had to have changed. I've not had to make any changes to it, but now I can create this cache of things that have happened against this file, and I know that's only containing the events that have actually happened. Another scenario for event processing is around application extension. So let's say during a particular season or particular month, we want to understand if a transaction is over a certain amount. We want to extend our application by driving some custom logic. Maybe that's deriving a set of extra offers or promotions for a certain customer. Maybe we need to trigger some fraud detection that only needs to happen during a particular time of the year. Now, this logic already exists, but we only want to drive it when this season is upon us. So we don't particularly want to go back to our prgbc program and start changing the logic of that application each time we want to turn this capability on or off. And that's the nice thing about event processing, is because the event itself is defined within a CICS bundle, I can enable that event and I can disable the event. And this means that even if prgbc is issuing a signal event, only if the bundle that contains the capture specification is deployed will that event be captured. So this means that I can effectively turn my eventing capability on or off as my needs require it. So I don't have to worry about changing the code or having 2 versions of the code. I can just choose to capture events and turn off the capture events as I need to, which gives us some really quite powerful capabilities. So that's event processing. I hope there's been some bits there you didn't know about event processing. I hope for some of you event processing was completely new, but I hope at least you've had a look at this and gone, ah, that could be interesting. I could try some of that stuff out. So next, like I said, we're going to talk about liberty and link to liberty. And of course, we can't talk about liberty without mentioning Java, and there are rules that I must abide by, which means that if I'm talking about Java, I have to show a picture of coffee beans. No one knows why, but they are the rules. I don't make the rules. So there we go, a picture of coffee beans. So why are we talking about Java, link to liberty in particular? So Java has had quite a long history in CICS. In version 4, so same time as we did EP, we started to migrate from a pooled JVM construct in CICS where each JVM could only run one CICS task. And that meant that doing things like having multiple threads were just impossible. We had to create a separate JVM for each CICS task that wanted to execute a Java program. In version 4 of CICS, like I said, we introduced the concept of a JVM server, which was a multi-tenanted proper Java runtime embedded inside of CICS that could allow multiple threads to run at the same time, and each of them be dubbed as a different CICS task, which meant they could then link to other programs could link to them, and in turn, they could share the same programming context. So they could roll back if the whole unit of work rolled back. They could update recoverable resources. And then in version 5, we started to build upon that capability and introduce the ability to run Liberty, WebSphere Liberty profile embedded within that JVM server. So just as a quick overview to Liberty, because before Liberty came along, we could run Java applications in CICS in our OSGI JVM server. So in that way, you could declare your application, you could package all of the Java classes that made up your application, deploy it to an OSGI application JVM server, and you could declare RDO CICS program definitions that defined the entry points into that Java application. This allowed applications written in COBOL or C or PL1 to link to applications written in Java. Now, when you look at Liberty, that isn't necessarily the same case, because with Liberty, most of your applications are started by Liberty listening on a port for inbound HTTP or HTTPS traffic. And when it gets a request on a HTTP port, it then takes that traffic and starts running a thread to process that piece of work. Now, most of the time in Liberty, that's going to be some sort of servlet processing. So you create a servlet class and you override the do get, do put, do post methods to define the processing that you want to do. And that processing may link to other Java classes in your application, which may in turn link to COBOL or C programs, your traditional CICS applications. Now, this separation between the servlet processing and the plain old Java or POJO object is quite similar to the separation of concerns between UI presentation logic and business logic when we were looking at a more traditional 3270 BMS application. And that link from the POJO to COBOL is simple, especially if you're using well-structured data in a channel and a set of containers. It's quite a straightforward thing to do. But what became clear was as the work or the applications within the JVM server, within the Liberty instance start to grow, we may start rehosting or creating new applications within that Liberty runtime. And this may mean that we end up with plain old Java objects within the Liberty runtime that aren't being called directly from HTTP, but they're being reused by servlets and other POJOs within the Liberty runtime. And obviously, it became natural to think, well, if this unit of this piece of capability is useful to my Java applications, could it also be useful to my COBOL applications or my C applications that I've already got running inside of CICS? How can I link to those objects or those POJOs from my traditional business logic? And you can't do it in the same way that you would link to a Java program running inside of an OSGI JVM server, because that application is going to be wrapped inside a WAR file. It's going to be deployed as a Liberty application. CICS didn't have the way of linking to that application apart from a socket that was owned by the Liberty JVM. So what we introduced was, so just to highlight that it's that link from our traditional business logic at the bottom of the picture to the Java component within the Liberty runtime that we're particularly interested in. So we introduced a new piece of capability in CICS version 5 called Link to Liberty. And what Link to Liberty allows you to do is to solve that problem, where I've got a Java application or a component, a POJO within my Java web application that actually I would benefit from linking to directly from a COBOL C or PL1 application. And we wanted to make that process of saying that this method within my application could be called directly from a non-Java application. So what we did is we added this @CICS program annotation into the Java code, which by itself doesn't do anything to the Java itself. It doesn't create any new things within the Java code. But that annotation is then used by the CICS annotation processor when we deploy an application that contains one of these annotations in it into a Liberty JVM server. And what will happen is that CICS will see this annotation when this application is deployed, and it will automatically generate the CICS RDO definition for, in this case, cust get. And it will generate that RDO definition and fill in all the blanks, such as the JVM server that it's running in, the program that we need to call. It will create all the connections to make this a CICS thread within the JVM server, and will install that RDO definition at the same time it's installing the application into Liberty. And this means that when this application is then installed into CICS, we now get a stub, an RDO definition for cust get, which can be linked to by any application. So this method here called getCustomer is going to get hold of the current channel, and then it's going to get a container called data off of that channel and create a reference to it. It's then going to create a result container, fill that result container with some storage or some data, and put that result back onto the channel. So what this means is that I can link to this piece of Java from a COBOL application, passing it a channel and a set of containers, and I can invoke it, let it do its job, and then get that container back. So it's solving that problem of allowing me to link to a Liberty Pojo application from one of my existing applications. So why is this important? Because it seems like such a small thing. Well, it comes back to this re-implement, rehost piece of in-step modernization that I talked about in the introduction to CICS session last week. We're seeing a lot of customers starting to consider moving and collapsing these multiple tiers of applications downwards as much as they can. And CICS as a mixed language application server really is perfect, or provides a perfect runtime to do that. So if I've got my Java EE application, I can now really consider about pushing that and running that within my CICS address space. Since version 5.6, we now support Java EE8 applications as just basically as movable entities between off-platform and CICS. I can take a Java Spring Boot application and I can migrate it without any code changes and run it inside the CICS JVM server. So if I can do that and I'm starting to collapse these layers, then I may have assets within that single physical tier that now I do want to reuse from Java EE or COBOL or PL1, and it's maximizing the co-location and the performance of those applications and the reusability of those assets that I'm now deploying into a single physical tier. So although from a implementation perspective, it's one annotation on one method, it's actually providing a whole load of extra value into Liberty and how other applications within the CICS platform can access those Liberty applications. So doing just okay-ish for time, I want to move on to our final part of the session and talk a little bit about system policy. So as I said when we were discussing event processing, when we came up with event processing in EP, we also created system events or system capture specs. So not only could I capture an event based upon a particular API call, I could also capture an event based upon the status of the system. And we added some support in there, and then we realized that actually both application rules and system rules were fairly different things. Understanding a business event and understanding a change to an application's behavior are fundamentally different things. So we've deprecated the original system events that we had within event processing. Event processing is still there, but that separate section is now deprecated and has been replaced with system policy. And in most cases, there's a one-to-one mapping between things that were available in system events and that are available in system policy. Now, in both cases, they both share the same underlying engine and capture specifications as event processing. So the internal algorithms that are used by event processing are reused by system policy. And what it does is it allows CICS to be controlled at runtime based upon a set of predefined policies. So I can start to say, well, if an application is going astray, maybe it's taking up too much storage, maybe it's making too many async API requests, I can actually police that within my system on a program by program basis and stop that from becoming more of a problem in my system. Or simply just count how many times this is happening. Do we have applications that are perhaps doing more processing or taking up more CPU than we actually thought? Can we just keep a watchful eye on those things and then work out if that's causing us a problem at a later date? So system policy introduces two types of rules: system rules and task rules. Now, system rules are all about the understanding when the state of the system, something within the state of the system, changes. So primarily, this is going to be when a resource status changes. So maybe the MQ.com becomes disabled, a file becomes disabled, a bundle now becomes enabling, those types of things. So the state of the system has changed in some understandable, pragmatic way. Task rules are about understanding when the behavior of an instance of a task is violating some policy. So this isn't about the resources that that task might use. This is about the things that it's doing. So is it taking up too much storage? Is it making too many storage requests? Is it making too many file requests? And understanding, allows you to basically place a cap on that type of processing and then decide what to do if a task were to violate that policy. Now, across both system and task rules, when each of those rules or those events are triggered, multiple things can happen. And the first two are the same across both system and task rules. And that is, we can either issue a message to the CICS job to say that a certain system or task rule has been triggered, and any information that was included within that message will be output. But also, like I said, this is built upon the EP engine. So we can also emit an event. And any way that you can emit an event with EP, you can also emit an event using system policy. So that means you can reuse adapters that you've built for event processing within system policy, if that is something that is useful. The only difference is between system rules and task rules in terms of their processing is that a task rule, one of the options you have available to you is to abend the task. So if you've got a task that's using way too much storage, that could start to become a problem. I can actually abend that task and kill it and roll back all of its recoverable resource updates. But with a system rule, where we're looking at the status of resources changing, I can also alter the ZOS WLM open status, meaning I can effectively turn a region off or on for receiving more workload if I detect that it may have been in a state where actually I don't want any more work coming across to it. So let's have a look at some scenarios. And the first one I've kind of hinted at previously, about stopping unruly transactions from taking over. So let's say we've done some diagnostic work. We may have put a case into IBM to help us diagnose why we may be getting a storage overlay or running out of storage in a particular region. And we can understand that actually TRX1, in some cases, there's a programming error, which means it can end up gobbling too much storage. And actually what we want to do is we want to put a cap on TRX1. We understand if it gets to a certain threshold of storage use, it's actually now going to just be easy. It's in a runaway state, and we need to stop that transaction before it goes any further. And what we can do is we can create a policy to abend the task when we get into that situation. So this is just a screen grab from the CICS Explorer, where I've created a rule called storage goblin, and its description: we're going to prevent TRX1 from eating way too much storage. And I've made the condition that if 31-bit task storage allocated is greater than 10 meg, which I think is actually a bit high, if I want to reduce that down a bit, but if TRX1 starts to use more than 10 megabytes worth of 31-bit storage, then I want to append the task. And that is just a normal system append. So the same rules apply to as it would with any other append. Now, because this rule is deployed as part of a CICS bundle, again, I can have this ready and I can deploy it maybe into my test region. So into a particular region first, I can turn it on, I can test it, and if needs be, I can also disable it and turn it off. So I can be very flexible about how I turn this on or off, and I don't have to change anything to do with my application code itself. Another scenario for system policy is perhaps I want to prevent work going to a particular bad region. So maybe I've got a TOR and I'm shifting work across 2 AORs. And in one of those regions, I get a bundle. I've got a bundle installed in both of them. And let's say that bundle goes bad and it goes into a disabling state. I want to prevent work going across there. So how can I create a policy to do exactly that? I could press the right button on my keyboard. That'd be a good start. So I'm going to create 2 rules within my policy. I'm going to create a bundle enable status rule and a bundle re-enable status. So my first rule will be if a bundle called bundle1 goes from any status into disabling, so it's starting to be disabled, then I want to set the ZOS WLM status to closed. Once it's set to close, that means it'll be it'll be a bad choice for workload to be pushed across to it. So therefore, work will go elsewhere and avoid this region. But of course, once that bundle has become enabled again and is now working, I want to undo the effect of that policy. So I can call bundle re-enable and same bundle. So I'm only doing this on the one particular bundle. And when this goes from disabled into an enabling state, then I want to reopen ZOS WLM. Now, obviously, these are fairly contrived examples. I could never go into the fine enough detail for every single particular customer, but the point of this session was to give you a little bit of food for thought on these different aspects of CICS that you may not have used before. So, in summary, first we talked about channels and containers. These aren't just about giving you a greater than 32 kilobyte COM area. They're far more than that. By using channels and using the presence of channels and being able to browse the number of channels on a container, you can actually provide a lot more meta information to the input and output data that programs use, which means you can start doing some quite clever programming techniques to actually create better applications within the enterprise. Secondly, we talked about event processing, allowing you to gain insight into applications, gaining an understanding of what those applications are doing, but also to extend applications by driving new logic when certain events happen within your application without having to change any of your existing programming code. We spoke about link to liberty, allowing you to go from a COBOL application or a C or PL1 application and link to a Java application running inside of Liberty by just adding a simple annotation to your Java code and letting CICS do the rest of the work for you. And finally, we talked about CICS system policy, allowing you to control and police different parts of your applications without having to write new application code just by deploying a new bundle. So in version 5 of CICS, we've just continued that evolution across the whole of the version 5 thought process, allowing CICS to become an unparalleled mixed language application server. And in doing so, we're building upon a whole load of capabilities that we really do think allow you to build world-class applications in a really cool way. CICS has the capabilities to allow you to do this. Thank you very much for your time.
Cheers, Will. I can't see any questions in the chat, but we'll give it a moment. And thanks for a run through of all these lovely tools that we've got available to ourselves in CICS now. I'm sure we might see them when we install new releases or IBM do an update, but do we have enough time to really take them in and see if we can add them in to make our lives a lot easier? Certainly some of that eventing ones are very interesting. And we've got not a question, but a bit of feedback, I think.
Oh, thank you very much, guys. That's really nice. Thank you. Lovely feedback.
Yeah, we managed to get up to 39 today, one less than your winning total so far from the first session.
Rats. I should have got some more people from Hersley to join and build up the numbers.
Yeah, that's a really good idea. Anyway, I'm sure the numbers will go down tomorrow. Tomorrow we've got our first user presentation. Some bloke from a bank is coming along to do a sort of rambling, nebulous conversation around interfaces for CICS, what we used to have, what we've got now.
I've heard
the
that guy
is.
likes curry, Rob. Is that correct?
Yes.
Yeah.
Yes, he's missing the curry house at the moment. Anyway, so yeah, I think it's an early one tomorrow, 9 o'clock. Might suit some people, might not suit others, but we've got 4 sessions tomorrow. So hopefully your diaries are all packed full if you can. Get away from your day jobs and spend a bit of time learning about CICS and educating. Please fill in the feedback forms. I'm just checking the chat again. Let's see, there's a few more. There we go. Just nice comments. So excellent. Thanks very much for your time, Will, and thanks for your presentation. And hopefully we'll see you soon. And
yeah,
see you all tomorrow. Don't forget to
good
fill
luck
in
for the rest of the conference. Bye.
Cheers. Thank you very much. Bye-bye. Bye, everyone.